In the name of Allah, the most gracious, the most merciful. Welcome back to my channel, Nadir Hussain AR. Last time we had set up our React project with next.js and we basically configured TypeScript, Prettier, ESLint and Husky to ensure that we push only that code which basically qualifies our quality standards, right, configured by us. As we had configured TypeScript, now in today video and in next couple of videos we are going to discuss TypeScript in detail to basically understand TypeScript and form our mental model that what actually TypeScript is, why we need it, how it is different from JavaScript, and what is types inference, which is basically a key feature of the TypeScript. What does TypeScript compiler do? Is it actually a compiler in its traditional sense as compared with the compilers of other languages like Java, or it is something different? And what are the benefits of the TypeScript, using TypeScript? Okay, coming back to our first point, that what is a TypeScript and what is its relationship with the JavaScript? Well, basically TypeScript is a superset of JavaScript. One thing. The second thing is it is actually it contains a static type system, right? These two things are the, it contains static typed system which basically models JavaScript runtime behavior. So first thing first, what does it mean by the superset? If we check its Venn diagram, here you see JavaScript is a kind of a subset and of TypeScript. And what does that mean? It simply means that every JavaScript code is a valid TypeScript code, right? But its converse is not true. Every TypeScript code is not going to be a valid JavaScript code, because TypeScript, in addition to this JavaScript code, it adds layers of the static types to the JavaScript code. That's why TypeScript code is not going to be a JavaScript code. However, a valid JavaScript code is going to work with the TypeScript, right? If we check its example, so here I had made a test.js. Let me open. So this is simple a JavaScript function, add function, which is adding two numbers. Basically, let me say divide, right? Divide. It is a valid JavaScript code. Has it opened the repository or not? And let open the repo instead of the file. Okay, so if we run it, node test, it displays, right? So it is however, if I change it to the TypeScript, which is simply if I change its extension from JS to TS, it is still a valid basically it is valid TypeScript code. However, TypeScript static analyzer, which will point out that basically you have not specified any types, static types for these variables. So TypeScript is implicitly supposing any type. We will cover this topic later, that what is any type and what is implicit any type, right? So for now, however, the purpose was to demonstrate that JavaScript code will work if you simply change the its extension, then you are done with the gentle migration. If we run it, it will still work. Note what it is saying. test the ts. Yes, it is working. Okay, now coming back to our agenda and the second point, we will discuss the static types system in detail. Today our basically uh, target is to cover the basics. Okay. The next thing was type inference. As you are seeing this error message, it is saying that parameter A implicitly has any type, but a better type may be inferred from usage. So basically, TypeScript has by default assigned the type any, but there can be another example. So let's suppose let age is 10, and I did not specify specifically any static type, but still if we hover over it, it says TypeScript has itself inferred from the value, this value which was assigned to this variable. TypeScript has itself inferred that its type is number. It is basically a key feature of the TypeScript, that it itself can guess the from the value that we assign. It takes decision. If developers has not assigned the type, then TypeScript itself takes the decision that what can be the type of the variable by checking the value. This is the key element, right, or the key feature of the TypeScript. This is the second thing that we have covered. The other thing is TypeScript compiler. In order to run the TypeScript code, we usually run a tsc command. So basically what TypeScript compiler does is, it does two things. TypeScript compiler, in actual it is not a compiler in the sense if we compare it with the compilers of the other languages such as Java, because compiler converts high level language code to the low level language code. In case of TypeScript is unique in the sense that TypeScript does not convert to the lower language. It just transpiles to JavaScript, plain JavaScript, which runs on the browser. It just transpiles, right, from one language. So basically on runtime, when we run this tsc command, TypeScript types are basically erased. Types are erased, and they have no effect when JavaScript runs. Simple JavaScript is generated from this basically TypeScript compiler. So basically the other thing that TypeScript compiler does is, it actually checks for the types. It transpiles. During transpilation, basically types are erased or removed, and before that it also checks for the types. These are two independent activities done by the TypeScript compiler. So basically as far as performance is concerned, if we see performance impact of basically, or overhead you can say, of TypeScript, then on runtime it introduces no overhead, because it simply transpiles to the JavaScript. Yes, on the basically build time, we basically takes some time. It takes some time. This process takes time. But on runtime, there are no performance issues, bottlenecks introduced by the TypeScript. What are the benefits? You will say, what are the benefits if TypeScript has ultimately transpiled it to the JavaScript? Then what is use of it, right? Why do we use it? Well, TypeScript helps us to catch runtime errors at the static time, right? So that in case of JavaScript, the issues that will be reported by users, with the help of TypeScript, they can be caught in the during development, and we can avoid them shipping to the production. So let's suppose if we write this function add a b, return a b. So in TypeScript I am going to specify the types to the parameters of the function, and my function expect that its parameters should be of the number types. So if I run this code, it basically I have not called the function, otherwise a static analyzer should point out. It is pointing that argument of TypeScript type string is not assignable to the parameter of type number. So it is telling us during the development that you are making the mistake. If I simply convert this file to the JavaScript, and JavaScript has no types, it does not complain. And if we run the code yarn or node test.js, it is going to work this in the wrong way. And if I perform division operation, then let's see what does it do. Not applicable, right? So TypeScript helps us to catch these sort of runtime errors basically during development at the static time. This is the number one benefit of the TypeScript. Other benefits are TypeScript basically when we are writing the code in the TypeScript, basically this supports IDEs like VS Code also works better with the TypeScript, like in navigation, in inspection of the variables, which basically improves the productivity of the engineers. So these are the core features of the TypeScript. In next video we are going to further cover the next advanced features of the TypeScript. I hope this has set the stage, or basically you have basically understood the basics of the TypeScript in this video. We will advance to the next concept in the next video. Thank you very much.